Hello everybody, I am Esra Alınca. This is the presentation of 491 special project. My project is constructing risk map of cyber entities belonging to Boğaziçi University in terms of security. I worked with Tuna Tuğcu in this project. The object of my dissertation is identifying the ways to exploit vulnerabilities to defeat the security features of system components used in Boğaziçi University. The goal of penetration testing will be determining whether and how a malicious user can gain unauthorized access to assets that affect the fundamental security of the systems. The process will include the use of manual vulnerability scanning or some automated tools, which will be written on Java or other programming languages, and the testing is composed of application and network layer testing, segmentation checks, and social engineering. Examples of vulnerabilities include, but are not limited to, SQL injection, privilege escalation, cross-site scripting, or deprecated protocols. My scope is in black box testing, external part scanning, DNS scanning, enumeration and exploiting, information gathering, and web application scanning and exploiting. And in the gray box testing, I will do penetration testing for web applications and web servers with partial credentials. And in the white box testing, penetration testing for web applications and web servers with IP addresses, source codes, network protocols, and diagrams. In the internal pen test, I will do post-scanning for internal networks, enumeration, man-in-the-middle attacks, operating system attacks, post-exploitation, antivirus tests, Wi-Fi pen tests, and firewall tests. And lastly, I will do social engineering attacks, and they are mail phishing and fake wireless API. In addition to tools which are Kali Linux, Nmap, Metasploit Framework, Foca, Hydra, Wireshark, an application or some scripts which try more than one XSS payloads, for example, is coded on Python. A comprehensive penetration test report is prepared for each application, which includes the necessary information to document the test and sent to the related teams in order to fix the security issues. I have found that there are 15 vulnerabilities in that point. 2 of them are critical, 3 of them are high, 2 of them are medium, and 8 of them are low severity. The scope of the project for this semester was scanning the following web applications: CMP boyun.tr, BNB boyun.tr, araştırma boyun.tr, and other applications. And the following vulnerabilities are detected in that applications. Most important, most critical ones were SQL injection, cross-site scripting, some form pages which can be automized, unencrypted transmission of data, admin panels found on the internet, and the others. Remote SQL injection vulnerability has been discovered in an application which has a critical severity. This vulnerability allows remote attackers to execute own SQL queries to compromise the web application or the web server. I use this vulnerability and 2 databases are dumped by this way, and usernames and passwords are leaked, admin credentials has been captured. The other vulnerability is XSS vulnerability. It is detected in many applications, which enables attackers to inject client-side scripts into web pages viewed by other users. Using this vulnerability, the cookie information is obtained and used for login without any credential. Another vulnerability is some form pages that can be automized are detected. Sending large amount of requests may result in disruption of service to stop in some applications. And the other is credentials are sending over unencrypted channel in some applications, which means sensitive information such as username and passwords are transmitted over HTTP protocol. So these credentials can be subject to sniffing. Attackers may obtain these credentials by sniffing the carrier and can access to the system. The other one is admin panels are found which are accessible to anonymous user on the internet. An attacker may exploit this vulnerability and takes control of the administration panel. And many other vulnerabilities are found. To summary, we may encounter more critical vulnerabilities. After finishing testing for the whole scope, it will be possible to make more precise comments on the cybersecurity level of the university. Let's see a demo of SQL injection. We have an application with a login panel here. Simply we type a username and a password, then keep the request using a proxy. Here, We have three parameters. Type is equal to 1, username is equal to test, and password is equal to test. Let's try one parameter, which is type, in this case, whether it is injectable or not. As you see, we type the command here. Request is our request. Our parameter is type. And it shows that, SQL map shows that the post parameter type might be injectable. So let's try for it. Yes, it found that it is injectable. SQL map suggested three payloads. If we try one of them, we can gain unauthorized access to the system. For example, one of these is Boolean-based blind payload, error-based payload, and time-based blind payload. I tried for Boolean-based blind. Let's dump the database, type, and DBS. We see that there are two available databases. Since we have database name, let's dump tables on it. By typing tables and database name, we see that we have 7 tables on the database. This is interesting. There are users. This users table may include username and password. So let's try for it. Here is the usernames and passwords leaked. If these users were a MySQL account, it would be possible to unauthorize access to the machine and do run root commands, which means doing everything on the machine. Here, the type 1 belongs to an admin user, and then type 2 biomechanics. And I am looking for another type 1. Yes, Volkan. Volkan is another admin user, so we can enter to the system as Volkan or admin as an admin user. Let me show you XSS demo. It is observed that a web page have an XSS vulnerability and an attacker can acquire login credentials, cookies, and sensitive information. The form inputs are entered as the following JavaScript codes. There were 5 inputs and they were replaced with these JavaScript codes: script alert name, surname, corporation, position, and other. As you see here, name, surname, corporation, position, email, and my JavaScript codes. And following alert messages come as desired. I showed just one, and I alerted the name parameter. If I want, I can use or inject malicious codes instead of these alert messages. The other vulnerability is some form pages which can be automized. Sending large amount of requests may result in disruption of service to stop in some applications. In this environment, for example, we have a form request new password is detected and many number of emails sent to the related email address by triggering email new address as seen figure. As you see, this is our request. I sent this request many times and this is my response. As you see, I sent esra.alinja@gmail.com. Maybe it cannot sync, but I can say that I was able to send 23 emails. Of course, I can more than this. Web application testing without credentials will go on in the future, and then gray box testings, which means testing web applications and web services with given credentials will start. Then there is internal test project and will be finalized doing social engineering attacks. In addition to this, some tools such as trying XSS payloads automatically will be developed and leave to the usage of the university. This is the end of my presentation. Thank you for your listening.